human exploration is defined by the immense risks taken to leave our home planet. From the earliest attempts to reach the stars, our journey has been marked by both incredible technological leaps and moments of profound danger. We have transitioned from observing the heavens to actively navigating the vacuum of space, facing the constant threat of mechanical failure. These missions represent a persistent effort to push past the limits of Earth's gravity and explore the unknown. In April 1970, the Apollo era hit a crisis when an oxygen tank exploded on the way to the moon. When the words, "Houston, we have a problem," reached mission control, everyone watched the three astronauts stuck in a failing spacecraft. They used whatever tools were available to steer the ship back toward Earth. This flight showed that even when things go wrong, you can still find a way home. It was a terrifying, messy, and ultimately successful escape. In 1971, the Soviet Union launched Salyut 1, the world's first space station. This mission represented a new milestone in the era of space exploration, moving beyond the lunar focus of the Apollo program. While the station's arrival marked a significant step in orbital technology, it also introduced the complex challenges of operating within the vacuum of space, setting the stage for all future long-term human missions. Halking main, which heisting in actually data, word, innovation quits, justing in everstay, word, in actually data, setting. Apollo 15 changed how we saw the moon. When astronauts drove the first lunar roving vehicle across the cratered surface, they moved much further than previous crews. This motorized trip changed the mission from a simple landing into a real survey of the lunar terrain. Instead of just touching down, they were actually traveling across a vast, dusty territory. The Apollo program's lunar exploration concluded in December 1972 with the Apollo 17 mission. As Eugene Cernan ascended back into the lunar module, he left the final footprints of the era behind. These tracks remain undisturbed in the airless lunar vacuum, marking the last time humans walked upon the surface of the moon. Following the era of lunar landings, NASA launched Pioneer 10 with a distinct objective. Engineers designed this spacecraft to fly past the outer planets and eventually enter interstellar space. As it traveled through the deep cosmos, the mission provided critical data from the outer reaches of our solar system, expanding our understanding of the environment beyond our planetary neighborhood. In Earth's orbit, the United States tested long-term space living by launching Skylab. As America's first space station, it hosted 3 crews who ran hundreds of microgravity experiments. Their work showed that humans could survive the physical and mental strain of space for months. This specific period of research provided the groundwork for the much larger ISS missions we see today. In July 1975, the Cold War tension eased when an Apollo capsule docked with a Soviet Soyuz spacecraft. This Apollo-Soyuz test project was a real moment of diplomacy, where former rivals shook hands in orbit. It proved that scientists can work together even when Earth's political divides remain deep. This mission showed that space exploration often ignores the borders we draw on maps. Viking 1 landed on Mars in July 1976. This historic mission represented the first time a spacecraft actually worked on another planet's surface, conducting complex experiments to look for signs of ancient life. Through its detailed imaging, it changed Mars from a blurry telescope dot into a real, physical world with a documented geological history. NASA launched Voyager 1 and Voyager 2 in 1977 to study the outer solar system. Both probes carry golden records containing Earth's sounds, photos, and greetings for potential extraterrestrial life. These spacecraft function as long-term messengers, built to continue traveling through interstellar space even after the mission's original engineers and controllers are no longer around. The mission's early years brought significant discoveries to light. During its flybys, Voyager 1 captured images of active volcanoes on Jupiter's moon Io and identified a thin ring system around the gas giant. These observations provided new insights into the complex environments of the outer planets as the probe continued its journey through the solar system. On April 12, 1981, the Space Shuttle Columbia launched, changing how we access orbit. This happened exactly 20 years after Gagarin's first flight, starting the era of reusable spacecraft. NASA designed the shuttle to make space travel more frequent and efficient, aiming to turn low Earth orbit into a regular destination instead of a rare, expensive trip. In 1984, Bruce McCandless changed spaceflight by performing the first untethered spacewalk. He used the specialized man-maneuvering unit jetpack to fly above Earth without an umbilical cord. This flight proved that astronauts could move independently of the shuttle, showing exactly how much control a pilot could maintain while disconnected from the spacecraft. But the shuttle era included terrible tragedies. Specifically on January 28, 1986, The Space Shuttle Challenger broke apart just 73 seconds after launch, an event millions watched live on television. The loss of the Challenger crew serves as a grim, permanent reminder of the actual risks involved in space exploration. We cannot forget the human cost of these missions. While things were grim on Earth, our robotic probes kept moving into the dark. In 1986, Voyager 2 reached Uranus, finding 10 new moons and 2 extra rings. Every image sent back changed how we view the ice giants sitting at the edge of our solar system. These snapshots made the outer planets look much more chaotic than we first thought. The mission peaked in 1989, when Voyager 2 finished its first full reconnaissance of the outer planets. By flying past Neptune and its massive frozen moon Triton, the spacecraft gave us our first close-up look at the furthest reaches of our planetary neighborhood. This era of exploration ended with a detailed map of the outer solar system, showing us exactly what lies out there. Following the launch of the Hubble Space Telescope, astronomers encountered a major technical hurdle. A flaw in the primary mirror resulted in the telescope producing blurry images. This defect in the optics meant that the mission's initial observations were compromised, presenting an immediate challenge for the scientists relying on the observatory's data. In 1993, a servicing mission was launched to address Hubble's optical flaw. During this mission, the crew installed corrective optics to fix the telescope's primary mirror. This hardware allowed the observatory to capture clearer images of the universe, enabling astronomers to study distant galaxies and the expansion of the cosmos. In 1995, the Space Shuttle Atlantis docked with the Russian Mir station, reviving the Apollo-Soyuz mission's intent. Former rivals ate together, ran joint experiments, and lived in orbit's microgravity. This period, 200 miles above Earth, showed that the station functioned as a practical laboratory for international diplomacy, rather than just a site for competition. In 1997, the Mars Pathfinder mission returned to the Red Planet, bringing the small Sojourner rover. As the first wheeled vehicle to drive on another world, it navigated the dusty air's valley's terrain. These tracks changed how we approach planetary exploration, proving that mobile robots could actually survive and move across Martian soil. Building the largest structure in orbit started in November 1998 when the first International Space Station module launched. This massive modular project required intense global engineering and unprecedented political coordination between various space agencies. By assembling these complex components over time, it established a permanent outpost in low Earth orbit, acting as a vital base for future missions deeper into our solar system. In November 2000, the first permanent crew boarded the International Space Station. Since that day, humans have lived in space without interruption for over 20 years. This long-term stay enabled scientists to study how the body reacts to microgravity and proved that people can actually live in orbit, paving the way for future deep space exploration. Space exploration changed when individuals entered the fray, specifically with Dennis Tito in 2001. He paid $20 million to visit the ISS, making him the first private space tourist. This trip proved that space wasn't just for government agencies anymore. It showed that private citizens could actually reach orbit, moving the industry away from being an exclusive club for powerful nations. The shuttle program faced tragedy in February 2003 when Space Shuttle Columbia disintegrated during re-entry, resulting in the loss of 7 astronauts. This disaster prompted an investigation into the causes of the accident, leading NASA to implement new safety measures for the remainder of the shuttle program's operations. While human flight struggled, our robotic eyes on Mars were uncovering new facts. In 2003, the Spirit and Opportunity rovers landed on the Martian surface to conduct a detailed geological survey. Finding evidence that liquid water once flowed across the landscape provided a massive clue in the search for life, fundamentally changing our understanding of the planet's history. Spaceflight shifted on June 21, 2004, when Spaceship One finished its first privately funded human mission. This historic flight started the new space era, a period defined by the rise of private companies and fast-paced engineering. It showed that reaching orbit no longer required government agencies alone, proving that commercial competition could actually drive orbital progress. In 2004, the Cassini-Huygens mission arrived at the Saturn system to begin its study. The mission's highlight included the Huygens probe descending through the atmosphere of Titan to land on the Moon's surface. These descents revealed a world featuring surface features, such as lakes and rivers composed of liquid methane. In 2006, NASA launched New Horizons toward the outer solar system, sparking scientific debate. That same year, astronomers voted to reclassify Pluto as a dwarf planet. This change happened because we finally started seeing the solar system structure as something more complex than just a list of planets, moving past our old, simpler models. In 2008, NASA's Phoenix lander arrived at the Martian North Pole to study the planet's environment. The mission's findings provided critical data regarding the Martian surface and atmosphere, contributing to our understanding of the planet's composition and the presence of water ice just beneath the soil. When NASA launched the Kepler Space Telescope in 2009, it started a massive systematic search for planets across the cosmos. Over years of observation, Kepler eventually confirmed over 2,600 exoplanets, including many orbiting within their stars' habitable zones. This massive dataset suggests the Milky Way likely contains billions of Earth-like worlds, fundamentally altering how we view our galaxy's potential for life. The Space Shuttle program ended on July 21, 2011, when the Atlantis orbiter touched down for its final landing. After 30 years and 1,335 missions, NASA retired the fleet, leaving a record of scientific data and the memory of lost crews. This retirement closed one chapter of orbital flight and forced NASA to pivot toward the next generation of spacecraft. But in 2012, NASA landed the Curiosity rover on Mars. The mission used a rocket-powered sky crane to pull off the most difficult landing ever attempted on another planet. Once on the Martian surface, Curiosity acted as a mobile lab, testing the planet's habitability with much higher precision than previous missions. While Mars rovers collected data, Voyager 1 reached a massive milestone in 2012. The spacecraft crossed the heliopause, exiting the Sun's protective bubble to enter interstellar space. This makes it the first human-made object to travel through the space between stars, moving beyond our solar system's edge into the deep cosmic void. In 2014, the Rosetta spacecraft dropped the Philae lander onto a comet's surface. This historic mission, operating 510 million kilometers from Earth, represented the first time humans successfully landed on a comet. It let scientists study the solar system's primitive building blocks directly, providing a physical sample of the early universe's material to analyze its composition. In 2015, the New Horizons spacecraft performed a flyby of Pluto. This mission provided the first close-up images of the dwarf planet, capturing its surface and features during its journey through the outer solar system. The mission's arrival at Pluto marked a significant milestone in exploring the distant reaches of our planetary neighborhood. In 2016, LIGO's first detection of gravitational waves confirmed Albert Einstein's prediction that ripples in spacetime exist. This landmark discovery proved that these waves are real, allowing scientists to observe cosmic events that were once invisible to traditional telescopes. This breakthrough provides a new way to study the universe's most violent movements. NASA launched the Parker Solar Probe in 2018 to study the Sun's outer atmosphere. The mission's goal is to fly through the Sun's corona, the Sun's outer atmosphere. By navigating extreme heat, the probe provides the closest data ever recorded from our star, helping scientists understand how solar weather works and impacts Earth. On May 30, 2020, SpaceX's Crew Dragon carried 2 NASA astronauts to the ISS. This historic mission marked the first crewed orbital launch from American soil since the shuttle retired, effectively starting a new era of commercial spaceflight. The mission proved private companies can reliably ferry humans into orbit, bringing a much-needed energy back to NASA's long-term exploration goals. In 2021, NASA landed the Perseverance rover on Mars. Its companion, the small Ingenuity helicopter, completed the first powered, controlled flight on another planet. This mission proved we can navigate the thin Martian atmosphere using aerial scouts, changing how we study the red planet's surface and terrain moving forward. In late 2021, NASA launched the James Webb Space Telescope, the most powerful observatory we have ever built. Engineers designed Webb to look back into the early universe and capture the first light from the dawn of time. This machine can actually see how the first galaxies formed and scan the atmospheres of distant Earth-like planets. In 2022, NASA proved we can defend Earth by crashing the DART spacecraft into the asteroid Dimorphos. This collision changed the asteroid's orbit, completing our first planetary defense test. It showed that targeted kinetic impacts actually work. We now have a practical method to redirect cosmic threats if they ever head toward our planet. In 2023, the James Webb Space Telescope proved its worth by releasing images of galaxies from the early universe. These views captured galaxies existing only 300 million years after the Big Bang, which contradicts current theories of cosmic evolution. Each new Webb image forces astronomers to update their textbooks and rethink how the universe actually formed. NASA is currently ramping up Artemis preparations to get people back to the moon. This isn't just a quick visit. The agency intends to establish a long-term presence, specifically aiming to land the first woman and person of color on the lunar surface. These upcoming missions serve as the necessary groundwork for much longer trips into the deep solar system. By 2006, space travel is changing. SpaceX is preparing Starship for crewed flights, and Mars mission planning is finally moving into its final stages. This isn't just theory anymore. People born decades after the Apollo missions are now training to travel deeper into space than anyone before them. We are moving past the moon and toward much more difficult, permanent destinations in our solar system. Space exploration proves that despite our small size, we can reach incredibly far into the void. We stopped just watching the stars from afar and started actually interacting with the universe through advanced technology. As we push into deep space, the goal isn't just finding new planets. We are searching for deeper answers about our own biology and history. Every mission helps us define our place in this massive, physical reality.